So today we're talking about the accuracy of the Bernoulli equation. Bernoulli equation is pressure plus gamma Z1 plus density over 2 velocity 1 squared is equal to pressure 2 plus gamma Z2 plus density over 2 velocity 2 squared, where here's point 1 and here's point 2. We know that pressure 1 and pressure 2 are both atmospheric, so they're 0. And Z1 is 0 because it lies on the Z-axis. So Z2 is h because here's our height and it rests on 2. And we know V1A1 is equal to V2A2, where A is area, pi over 4, diameter 1 squared. So you can cross out pi over 4 and you have velocity 2 is equal to V1 D1 squared over D2 squared. And you can plug V2 in from right here. And you have this equation over here. You subtract by this part on this side, so your V's are on the same side. So then you have to divide by density over 2 on both sides, and then you have to take the square root to get rid of these two squares. We know that gamma is equal to density times gravity, so gamma over density is gravity. So then you have the square root of 2gh is equal to v1 minus v1 d1 squared over d2 squared. So v1 is equal to square root of 2gh over 1 minus d1 squared over d2 squared, where gravity is 9.81 meters per second squared. The height is 0.18097 meters. Diameter 1 is 0.0170 meters. And diameter 2 is 0.021844 meters. Now you look at the velocity equation. Velocity is displacement over time, where the displacement will be our h and time will be in seconds. The velocity will be the number that we get over here, and our h is again 0.18097 meters. So now if we plug in those numbers that we just got into our equation, our velocity is 4.78 meters per second, and our time is 26 seconds. If the time falls between 24 and 28 seconds, I have a 7% error. So here is my experiment. I have two Gatorade bottles where here's the z-axis and here's the height. They both should fall about the same rate, and there will be our time. Okay.
3, 2, 1, go.
That looks pretty cool. Ooh, right on the money, 26 seconds. So there is my Bernoulli equation, and it was right.